Hello everyone, welcome to my channel. In our previous session, we have started the solutions for exercise questions of work and energy. Let us continue the session. In the third question of work and energy, a battery lights a bulb. Describe the energy changes involved in this process. So what happened? A battery is lighting a bulb. So what happened here? When a bulb is connected to a battery, the chemical energy, the, the chemical energy which is present inside the battery start converting or start transferring into electrical energy. This electrical energy converts into light energy. When light is giving out, it produces little amount of heat energy also. That's why we are written here plus heat energy. We are not written the arrow mark here. Light energy is not converted into heat energy, but light energy as well as heat energy are produced. So when a bulb is connected to a battery, then the chemical energy of the battery is transferred into electrical energy. When the bulb receives this electrical energy, then it converts it into light energy and heat energy. Hence, the transformation of energy in this above situation is given as chemical energy into electrical energy into light energy and heat energy. Let us go to the fourth question. A certain force acting on a 20 kg mass, its velocity from 5 meter per second to 2 meter per second. So initially the velocity of the object was 5 meter per second, then it is decreasing here. Calculate the work done by the force. So let us write the given terms here. Given mass is equal to 20 kg and it velocity changes from means it's the initial velocity of the object is given by 5 meter per second and final velocity is given by 2 meter per second. We need to calculate work done by the force, that is kinetic energy. Why we have taken here kinetic energy? Because the object is in the motion. Whenever the object is in the motion, it's considered as kinetic energy. So we know the formula for kinetic energy here, that is kinetic energy is equal to half mass into velocity square. But here the velocity is changing, so we have to take change in velocity. That is change in velocity is nothing but final velocity minus initial velocity. Instead of writing here v square, we have to write it as v square minus u square. So let us substitute the values. Mass is 20, v square is 2 square, that is final velocity, u square is 5 square, that is initial velocity. Let us go for the further calculation here. 2 ones are 2 tens are here. So what I'm doing, 2 ones are here, 2 tens are, and then 4 minus 25 is minus 21. So altogether answer is minus 210. So minus 210 is the work done here. So why there is a negative sign? Because the velocity is changing. The object was in the motion and velocity is changing. So the negative sign indicates that the force is acting in the direction of opposite to the motion. It has decreasing. So we got here negative symbol. So whenever the answer is in the form of negative, we have to write the reason why there is a negative symbol. Let us go to the fifth question. A mass of 10 kg at a point on a table, it is moved to a point B. So there is a table and then a, an object is having a mass of 10 kg. So here is an object. So here is a table and the object is having mass of 10 kg. So it is moved to a point B if the line joining A and B is horizontal. So what happened? The object is in the motion in one direction, but the force towards the gravity is towards the down direction, so there is no height. So when object is having some mass, its vertical displacement should be known. Here there is no vertical displacement. Already we discussed such type of questions when they have the perpendicular formation, so there is zero work done. Or mathematically, how can we prove? Work done by gravity depends on vertical displacement. There should be the vertical displacement, but in this case the object is in the horizontal displacement. If the object is kept in somewhere, so we can calculate the height of the object. So that mass is given, height is given, acceleration due to gravity also we know, we can calculate the work done here. But the object is in the horizontal place, so what happens, there is an acceleration due to gravity towards the earth and they form perpendicular. So when there is a perpendicular between the force of attraction as well as the movement of the object, we say work is zero. So let us take the calculation part. Therefore, work done by the gravity is given by the expression W is equal to mass gravitational towards earth as well as height. Here we don't know height of the object in this case, so we say height is zero because there is the point, the initial point and final point of the object is horizontal. Whenever the work is towards the ground, the vertical displacement should be calculated. So here h is 0, so when we calculate we are getting the answer as 0, that is nothing but 0 work done by the object. Let us go to the next question. Sixth question is, the potential energy of a freely falling object decreases progressively. The potential energy means the object is at a certain height. The object has placed certain height. Here is one object. It is some particular, already it is at the particular height from the ground, and does this violate the law of conservation of energy? So when object starts falling towards the ground, so what happens here, as we discussed in our discussion part, the object is certain height, and it's when it is at the height it has some potential energy. Here what happens, when it starts moving towards the ground, it gains kinetic energy. So what happened here, the potential energy has been converted into kinetic energy. So when it starts moving towards the ground, it gains the kinetic energy. So potential energy is transformed or converted into kinetic energy. Whenever there is a transformation of energy, there is the law called law of conservation of energy. So is it violating any law here? Certainly not. So what we have to write here? No, the process does not violate the law of conservation of energy. This is because when the body falls from a height, then its potential energy changes into kinetic energy progressively. A decrease in the potential energy is equal to the increase in the kinetic energy of the body. It starts reducing, it starts losing its potential energy so that it can move towards the ground. So potential energy decreases, kinetic energy increases. So during this process the total mechanical energy of the body remains conserved, that is potential energy is converted into kinetic energy. There is a transformation of energy in this process. So this situation does not violate the law of conservation of energy. Let us go to the seventh question. What are the various transformation of energy that occur when you are riding a bicycle? So you are riding a bicycle, when you are riding a bicycle, you want to pedal it. When you are pedaling, you are using muscular energy. That muscular energy is converted into kinetic energy. How kinetic energy? Because the bicycle starts moving. So muscular energy is converted into kinetic energy, and heat, also heat is produced. How heat is produced here? While riding a bicycle, the muscular energy of the rider gets transferred into heat energy as well as kinetic energy, because there is a friction between the pedal. So there will be a less amount of heat will be produced. So what we are writing, muscular energy is converted into kinetic energy plus heat energy. So during the transformation, the total energy remains conserved, means there is a transformation of energy here. Hope these answers are clear to you. Let us meet in our next session in continuing the solutions for the exercise questions of work and energy. Thank you. Thank you for watching.